squares. Now, the reason why they're called difference of perfect squares, there is an array, which we will unpack a little bit later, but I just want to get through a little bit of the content, just the skill to get through it. Now, if you recall, one term needs to be positive, another term needs to be negative, okay? And you'll find that there's 0 of the powers of 1, okay? Like there's 0 variables like x to the power of 1. So we've got 0 x's in this case to the power of 1. We've got none of those, tick. And we've got 1 positive and we've got 1 negative term. Tick, okay, 1 positive and 1 negative, tick. Okay, so we can see that this is going to be a difference of perfect squares. So I can just square root these, and the one that's positive is going to stay positive in both of those, and the one that's negative is going to have a negative and a positive. Why we square root them both is because we need the 7x to cancel out with the minus 7x, and that's a difference of perfect squares. So I hope that makes a bit of sense there with those. So again, I could have rewritten this the other way, 49 minus x squared. I've got 0 x's, correct. And I have 1 positive and I have 1 negative. Correct, so this would be 7 would be positive in these cases. And I would then have 1 positive x and 1 negative x. And that would be it there. All right, so then we can see that that would be 7x minus 7x, and you get the no x terms. So again, like even if you've got, I'll just do one out of the book. These are all questions 1s. Okay, here I've got, and that's squared, I've got 0 ab to the power of 1. Notice there's none of those. That's what we're looking for when I'm saying no x terms. It's none of those. 1 positive term, we've got 1 negative term, tick. So that is going to be positive 6. I square root both of these. That's 6a for both of these. That's going to give me positive 36a. And one of these has to be positive. It's going to be b. And that has to be negative. That's b. That's going to give me negative b squared. That'll give me negative 6ab, positive 6ab. That's 6, by the way. And that would be my difference of perfect squares. We're going to look at a little bit something different when we're factorising these, which will be, just slightly different. So there is, you'll find later on, you'll get to some questions that are something like this. Okay, and whenever you're factorising, if you're ever asked to factorise, the first thing that you should always do, don't care what sort of factorising it is, in any form, if you ever see the factorise, the first thing that should always come to your brain, okay, this little brain of yours with your central nervous system, the first thing that should come to your brain out is TUCF. TUCF who? Take out common factors. Always do that first. That will take you all the way through to Year 12, the whole way through. The first thing. Question says factorise. Oh, can I TUCF? TUCF what? Take out common factors. So if I've got a question like this, I should take out my common factor first. Now, some people may say, oh, this is 2y minus 8, 2y plus 8, which would give you negative 64. That will cancel out with that, and that will give you 4y squared. Yes, but really, we should be taking out our common factor first, okay? So we always want to make sure we take out a common factor, and then we can factorize it afterwards, which is where we want to go with this one. So don't do that. Take out my common factor. Can I take out a common factor of this? Oh yeah, 4. And that's going to give me y. And that would be 10 would give me 40. And I'm left with 24. So that would leave me 6. So that'd be 16. Y squared minus 16. 4y plus 4y minus 4. Always take out a common factor first. How does this transform to that? What you can actually do is take out the 2 as a common factor from this, which would be 2y minus 4 times by 2y minus 4. As you can take out 2 from that as well. And 2 times 2, then you can just rewrite this because this is all times, right? 2 times 2 times y minus 4, y minus 4. So you can take them out later, but it just gets a bit trickier and you'll get to the same answer. So when we're asked to factorize, the first thing you should always be enlightening your brain to is, can I tukuf? Can I take out my common factor or not? And that is really important that you do that, okay? So please make sure that you always take out your common factor first when we're going through that. I'll just do one more example of this for you guys. So if I've got, let's go with, here you'd be like, oh, how am I going to do this? Because this has a power of 1, okay? So you might go, hey, 0 to the power of 1s. Oh, no, but it does have 1 positive and it does have 1 negative. But if you take out your common factor first, now in the brackets, it's got 0 y's. 1 positive and 1 negative. Now I can do the difference of perfect squares for that. What are we doing? That's positive, so it's going to be xy plus 1. Square root of 1 is 1. Xy minus 1. And that would be it there. So please make sure, first, tukuf. Take out your common factor. I call it tukuf. I don't know if any other teachers do. I just think it sounds cool. All right, the last thing we're going to look at, which is sort of question 5 onwards, which is a little bit different to completing the squares, but it's a technique you'll use later on with quadratic as well. Factorising, I suppose, putting it in, but you can look at it as it's a bit borderline of difference of perfect squares, but it's basically reintroducing it back in. So if I've got like this thing, a squared, right? And let's just say it's minus 4. Well, I can go, oh yeah, that's just going to be a plus 2, a minus 2. Hopefully you guys agree. Now, if I've got this other thing where it's like, let's pretend a is something else. Let's call it x plus 1 all squared. So that's what a is, right? That's all squared minus 4. Well, that's going to be x plus 1, because that's what a is, right? Plus 2. And then you're going to have x plus 1 minus 2. Really? All right, let's get in. And then we've got that one there. Okay, so there's minus 2. So then we can simplify this. So that's going to be, x plus 3, x minus 1. So we have a couple more of those. So going off this principle, I'm just going to do another one. Let's go with a squared minus 16. Well, you're going to go, hey, that's a plus 4. Hopefully you're saying it's easy. A minus 4, right? But let's just say that that isn't. That's this other thing that's in a bracket. So it's like x plus 10 all squared minus 16. So what you've got to see here, because this is all squared and that's minus, and again, there's 0 x's kind of in the way it's expressed. There is actually x's if you expand it, but in the way it's expressed, that's why I don't really like it. We can treat this as a difference of perfect squares. Oh, so that's the positive section. So that has to go in x plus 10, x plus 10, because I've square rooted it, because it's squared. Notice, because it's only squared, it's like that's a, okay? That's where a would go. Notice, because it would be a plus 4, a minus 4, right? So this is a, it's explicit, and that would be then plus 4 minus 4, because that's the negative section. So what I'm trying to say is that the 16 goes here, and your a goes there and there. Well, instead, this thing's kind of like a. So this goes here and here, and that goes to plus or minus 4. And then we can just simplify that. So that would be x plus 14 and x minus 6. So I'm just going to show you one that's a little bit different. So if I have, for example, 81 minus a squared, you're going to be like, oh yeah, 9 plus a, 9 minus a, right? You're probably going to guess where I'm going with this. 81 minus x plus 4 squared. Oh, well, that's easy. 81 minus, oh, let's do plus first. 91, square root it. 9 plus x plus 4. You'll see why I always do it in brackets. 9 minus x plus 4. Now make sure you do it in brackets, these ones, because some people, because you'll notice this is 9 plus x plus 4 in this bracket, but this is 9 minus x minus 4, because you're minusing those things. Now, if you don't put in brackets, it'll turn out to be 9 minus x plus 4, which is not right, because you're actually minusing that whole thing away, okay? So you just need to be wary of that. Notice that's why I actually put them in brackets, and I should have put them in brackets here too, inside my brackets when I substitute those in, just in case if it's on the other side. When you get more fluent, and you can probably drop them off. So then I can simplify that. That's going to be x plus 13. And this is going to be 5 minus x. Or I could write it as negative x plus 5, but yeah, it doesn't really matter. And that's x plus 13. And that's how we do those. So the same process that you would use, it just looks a bit differently, but just be careful of your brackets and how you do that. I will do just the last one of this. 4 minus x plus 2 all squared. Can I take out a common factor? No, I can't. So 4, that's going to be 2. That's going to be 2, right? Because that's a positive. I have to have a positive of x plus 2, because that's all squared, because I'm square rooting it, minus x plus 2. Notice I put in brackets. That's going to be x plus 4. That's going to be x, because 2 minus 2 would be 0. So therefore I can actually write that as x plus 4. And that is it. So that's pretty much everything from there. You can also do it with fractions as well. So let's just have a little bit of a look at fractions, which we'll probably come to. I did. Okay, if you think about this, that'd be x. That'd be x. The square root of 4 is 2. The square root of 25 is 5. Because when you times this by this, you're going to get negative. If you think about it, you're going to get negative 2 on 5 multiplied by 2 on 5. That's going to give you 4 on 25. And they will also cancel out. So that's another one. So I'm going to leave it there. Best of luck. If you've got any questions, please let me know.